Hi, in this last video, I'm going to show you how to convert between raster and vector and finish this analysis in the vector data model. So using the raster calculator, we worked through part 2 of the analysis where we combined slope and aspect to get the mean, we incorporated land cover to get this first result, and then we used the raster calculator in a Boolean operation to filter out the areas that met our thresholds. So at this point, we have incorporated slope, aspect, and land cover, and we have two more criteria, suitable soils and size. And to do those, we're going to need to convert this to a vector data set. So we'll use this tool called polygonize to polygonize that final result. And then we're going to incorporate soils, which is a vector data set. So we're going to select the suitable soils using an expression, and we're going to dissolve that selected set to end up with a suitable soils layer. At that point, we can use a vector clip operation to clip the final result by the suitable soils, and then we'll have raw potential vineyards, and the last criteria we will have to address is size. So we will calculate the hectares for those final potential vineyards and select the final ones that are greater than or equal to 1.7 hectares to get the final answer. So I'm going to get out of PowerPoint and into QGIS. So I want to polygonize this final raster result. So I'm going to go to the raster menu, to conversion, and choose polygonize raster to vector. You'll notice that there's also a vector to raster tool that you can use to go the other direction. So polygonize takes an input, which is our final result. It's going to output a new column that has the pixel values, and the standard for that is DN for digital number, and I'll go ahead and use that. And I'll save this vectorized out to a shapefile, and I'm going to call this final result poly. Click save. And I'll point out that this polygonize is a Google tool. So it's one of the GDAL command line options, and so whenever you run one of those in QGIS, it gives you the command line equivalent of what you're running via this graphical user interface. So I just want to point that out. So if you ever want to explore that command line environment, this is a great way to get started because you already know the command to use in the command line environment for what you're about to run. So I'll click Run. Okay, it's finished. So I will close this dialog. So this is every pixel from our analysis. And so what we want to do is look at the attribute table. And we're only interested in the ones where the digital number value equaled 1, which would be potential vineyard sites. So I'm going to put this table into edit mode, and I'm going to open up the select features using an expression window. And I'm going to expand fields and values, select my field digital number, get all the unique values, and I'm just interested here in the ones that equal 0 because I want to get rid of those. So I'm going to select all the records where DN equals 0 and click close, and I'm going to remove those, delete those selected features from my data set. So now I only have the potential vineyard sites left, and I'll save this. So now I have my final vineyard sites as a vector data set, and you can compare that to the previous raster one and see that it's the same. And if we explore this a little bit, you can see that these are pixelated. If you zoom in, these are, because it does keep the polygon boundary, so we have our 2 meter pixels still evident in the vector shapes. Okay, so now I want to incorporate suitable soils. So I'm in my browser panel. I'm going to expand my favorite for the raster data course, and I'm going to go into the vector data and find the soils data set and add that to my map. So here are my soils, and I can see the legend of the different types that we have, and there's an attribute value called TSYM that we have a legend entered for, so we have these in English. And I'm interested in just 3 of these, the glacier meltwater clay, the glacier meltwater sand, and the clayey till. So I'm going to open up the attribute for this data set, and I'm going to again select features using an expression. And I'm going to put the expression in where this attribute field, TSYM, equals DL, DS, or ML. And I'll select those features and click Close. So I have the suitable soil selected. And now I'm going to run the vector dissolve tool on this selected set. So I'll go to the vector menu, geoprocessing tools, dissolve. I'll accept soils as the input layer, and I want to make sure to use only selected features. And I will save this out. And I'll call this suitable soils. Here I'm saving these out to shapefiles. It really doesn't matter if we save these out to geo packages or shapefiles. They're very simple data sets, so the data type doesn't really matter. Click Run and close. So now I have a suitable soils layer here. And now I can use the clip tool, so all the final result polygons that are still visible are not ones that would be suitable because they're in unsuitable soils. So I'm going to use the clip tool to clip the final result poly by suitable soils. So go to the vector menu, geoprocessing tools, and find clip. And I'm going to clip the final result poly by suitable soils. And I'm going to save this final vineyards. Click Save and Run. Click Close and drag my final vineyards as the uppermost layer. Turn off these other layers. So here I have my final vineyards. And the last criteria now is size. So I want to compute the size for these. So I'm going to open up the attribute table for my final vineyards, put it into edit mode, and I'm going to add a new field, and I'll just call it HA for hectares. Set this to a decimal number real with a precision of 1 because we want to identify sites that are greater than or equal to 1.7 hectares, so we need a precision of 1. I'll click OK. Now I can calculate that hectare value using an expression. So QGIS has a dollar area function. So dollar area is in the geometry section, and it returns the area of the current feature in coordinate units, which are square meters. So I'm just dividing this times 10,000 so that I get hectares. I'll click OK and update all. And I'll save my edits. And if I sort this column, you can see that I indeed have some features that are greater than or equal to 1.7. So those selected polygons are the final answer here. These are areas that are suitable in terms of the criteria that we've selected so far: slope, aspect, land cover, suitable soils, and size. And I will point out that there's also a great plugin for computing geometries for fields. There's one called Calculate Geometry. I have it loaded here. And so when this plugin is installed, when you right-click on a vector layer, you'll find this Calculate Geometry option. So you can use this plugin to do the same thing. I could choose my hectare column and tell that I wanted the units in hectares with a precision of 1, and I'm not interested in perimeter, and I could do the same calculation. So you can calculate this value either way. And it should give you the exact same answer. So what I can do to finish this is enter a filter for this. I go to the Source tab of Layer Properties, and in the Provider Feature filter, open up the Query Builder and enter an expression hectares greater than or equal to 1.7. Test it. And if I click OK, I will have the final result on my map of the final potential vineyard locations.